getting this friction factor evaluated from pressure drop versus distance. Okay, here the starting from this entrance, we are given with this pressure measurements. Okay, we need to get the friction factor. In the flow is fully developed conditions. At the inlet, the flow is getting developed only after certain length only. The fluid will be having a fully developed flow. So because of that, actually the initial pressure measurements will not be matching to the equation of fully developed flow. So let us see this. Say we can evaluate this pressure drop over each and every length 1 meter of this pipe segment. So we see that this based on the data here. This difference is 53 and here it is 40. Okay, like that. This difference is keep on decreasing, and after certain thing, this difference is the same, which indicates delta P by L is a constant. There is a requirement for a developed flow. For a developed flow, this pressure drop per unit length is a constant. Of course, we are using this equation based on this case of fully developed flow. So till this, we have flow getting developed. So from then on only the pressure drop data is a constant. So we have to use the data at the developed conditions. So we have this delta pressure, which is the difference is delta P. Delta P by L is available readily, and from that, and we are also given with this density as well as velocity and diameter. So velocity, diameter, density are available. So you can easily get F value. So F is fanning friction factor because this relation 2FL rho V square, this F is fanning friction factor. Whereas in civil mechanical books and all, you will be having the relation what is called as FD or FB, what is called as Blasius or Blasius or Darcy friction factor, which is actually 4 times this value. And because of that, instead of 2 here, we will be having 2 in the denominator. Actually, the civil books, we won't be having 2 here. Instead, 2 will be there in the denominator. And F, it is referring to Darcy friction factor. Okay, and that books also will have this F 64 by Reynolds number in the laminar portion, whereas we'll be having 16 by Reynolds number. So using that, you can easily get the relation between Darcy's and fanning friction factor. So the F what we use is fanning friction factor. Fine.